In this, the inaugural episode of Messing Around with AI, I'm interested in looking at Groq, Groq. And right off the hop, they're telling you the differentiator for their company, the language processing unit, the LPU. So their big claim to fame, their main value differentiator is that they are making LLM, large language model specific hardware. And I get the impression that we're about to run some models on that hardware and see that it's much faster. Makes a lot of sense. GPUs were not optimized for AI matrix multiplication. Maybe they were, but they were not built for large language models specifically. So you'd think if you customize your hardware, you're good to go. And this is interesting because I have not actually played with Mixtral 8.7b. So I'm excited to see that. Bam, right into it. They didn't ask me to log in. So I'm expecting very fast performance here. I'm wondering if this total requests down here, 3.4, if that's specific to me, if this is the maximum that I have under freebies. We'll find out right quick, won't we? As a first request, let's see if it knows about itself, its own company. Does Groq have its own model, or is it going to only be a hardware company? Oh man, that speed. Yes, this is what we're talking about. This feels like the future. I didn't see if that decremented. I gotta keep an eye on it. 202. So not too surprising. It's talking about how they do not have their own model, at least not yet. Come on, give it time. I almost guarantee it would not surprise me at all. But it does have some software on board, which is not surprising. They have the architecture that allows these models to run on it. And there's a specific branding, the Groq Tensor Streaming Processor, TSP, a specific Groq compiler to convert your framework from things like TensorFlow, PyTorch into the Tensor Streaming Processor. Okay, so they have about what I expected, that this is all about running different models on their hardware, and it's amazing that they have this up and running. This came out of left field for me, that we had an actual implementation of the hardware running. And this is a Mixtral model, so that does help with the speed. I like how they have pointed out they're running at 530 tokens per second. It is slightly slower than the original terabytes per second. I was wondering if it was. I've seen people compare the speed of this to ChatGPT, which very much is apples to oranges, I'm realizing. Because Mixtral 8x7b, of course, is running inference on 13 billion weights or so. So this is definitely the best of both worlds, where it's running a small model on dedicated hardware. But it's still a delightful experience, so why don't we give it a run for its money? I haven't dealt with Mixtral yet properly. So this is great. And I didn't pay close attention. I'm going to write this down because I believe this number has gone up. Wasn't it 3,400,000? It was 200 and something. I don't think this number is going down. I think it's going up, which would indicate to me that it is the total number of requests to the system. This little test I've done before to test out reasoning. Lisa says she's been to every country in mainland Europe, but she hasn't been to Paris. Does that mean she's lying? It's a logic test that I evolved to see if the system... that was interesting. It took a hot second, just a fraction of a second to think about it. And I'm like, oh, did something hang up? I didn't see where it was generating on top of it like this. I do have to say, I'm interested in their GUI and how they build upwards on it. New stuff on the top of the pile. For context application, I've been looking at doing it that way around because it's a different paradigm, but it makes a lot of sense. New stuff goes on top. Right off the hop, it does get the answer correct, that not necessarily lying. This is a really great breakdown. While Paris is a city in mainland Europe, it is not a country. Therefore, she could have visited every country and not been to Paris. But it goes on to say, if she had claimed every place or city in it, then her statement would be sus. This is impressive. I am glad that I jumped in to test out Groq with you so that I could get my hands on Mixtral. I'm interested to see its capabilities. Usually people put a stress test on models with their ability to code. And I have yes, you need the most horsepower for it. I appreciate the GPT-4 or whatever the state of the art is going to be when I'm trying to do a complex UI real world application. But I'm not expecting a lightweight model to be able to do that. What I'm looking for is a balance of performance from it. And what I've been seeking and not finding is this increased reasoning ability, which people, when it came out, said Mixtral had. Let's try something different. What comes to mind is what its knowledge cutoff date is, and just confirming that it does not have access to the web. Do you have access to the internet, and what is your knowledge cutoff date? Man, that is fast. 530 tokens a second. Knowledge cutoff is 2021. Now I don't remember, is Mistral being trained off of synthetic data out of one of the GPTs? And just like coding ability, I'm okay with limitations around the knowledge cutoff date. It's great to have a single model that you'll be able to access current information, or Perplexity I've had good luck with if I want to find something in an intelligent way or summarize news stories that are coming out. That's working well. But for evaluating a model for use in tooling and for pure performance, I'll make that trade-off. It is interesting that it's coming from 2021 era. And I just confirmed it by writing it down. 3,421,000. This started out 3,418,000. So in the past however many minutes, they had 3,000 requests come through. And because that's not ticking up faster, that has to be legitimately requests to the system. I'm impressed. I am looking forward to finding... Actually, let's do that. Let's find out more about the company. Ooh. Project Know-It-All. Increase the knowledge of LLMs with contextual information via RAG integration. Man, I have this vision for a new paradigm of computing, and I swear one of these, just out of the blue one of these days, one of the model companies like this one are going to come up with a category killer and make my efforts obsolete. Part of the reason I'm trying to stay on top of these models, because I want to remain pertinent after they totally obliterate any need for the tools that I'm making. Let's launch the demo on this guy.
Hey, Alec with Groq here. Today I want to talk to you about Retrieval Augmented Generation, or RAG, with the Groq API and a vector database. I think we all know that large language models have played a transformational role in how we interact with information. However, like any new technology, there are a couple limitations. The first is that their knowledge is static. Once they're trained, they don't continue to learn.
This is pertinent for a 2021 cutoff.
Through a method called fine-tuning. Fine-tuning is not only costly, but it requires deep technical expertise. The second limitation is that these are generally absent of domain-specific knowledge. Large language models are generally trained on a lot of
yes,
open source information.
Yes, we understand the limitations. What's your solutions?
To alleviate some of these limitations.
All right, let's pause on the diagram here real quick. He did say a vector database, and I thought he said something else, but no, it's specifically to the vector. The example is, why was my water bill so high last month? All right, let's see this demo, because this seems to be polling, yes, from your specific information.
On the screen, you can see what a RAG architecture looks like. At the end of the day, you just need to connect data from your database into the large language model. For this demo, we're using Pinecone, and Pinecone is a popular vector database.
Ye old Pinecone.
In that database, I've scraped
they're starting at the same point
articles
most people do.
From the BBC, starting in January 2023 up until the end of December 2023. If I'm a user, I might ask the following question to my system.
Let's jump ahead.
A year or two ago. So it's searching, finding the most relevant information, and you can see without a RAG architecture, the large language model responded with.
Okay, so I'm not seeing anything super crazy here, like they're fine-tuning their own model in order to work with a hybrid RAG approach. They're pretty much starting out where everyone else did a couple months ago with Pinecone as a vector store for information. It's good that it's on the radar. I'm curious how it'll pay out for them, but nothing too earth-shattering here. So it looks like they are also accelerating image generation. Can't remember what project it was that might as well answer my own question. What project was it that allowed that real-time editing of the prompt? And it took a few minutes, a few seconds to search things, and we're seeing the text be generated. I did it with Copilot on, which is what, 4.0? And it didn't find what I was looking for. When in doubt, we'll go to futuretools.io from M.A.W.A. Dark mode, light mode. And I guess I'll do the generative art one, which is an interesting categorization for text to image. Look, I'm not making this up. He definitely covered something that was allowing you to edit the image in real time. I'm interested because it says launch the demo and it's direct to a YouTube video. So a demonstration in their mind is not something you can play with. But hey, I'm not going to hold it against them because they're giving us access right here. API access. What's this button do? Llama 2 70B. I've mostly been playing at the deep end of the pool when it comes to models. As the API for Llama 2 is what it looks like. 10-day free trial, cost. I was scared there for a minute because I saw the 70 cents. I saw 300 tokens. I'm like, that's pricey. 70 cents per million tokens. Let's see what the price is on OpenAI 3.5. It's interesting. The prompt price is cheaper than the inference. Don't think I realized that. So if I'm moving my decimals right, the API for Groq is significantly more expensive for the 4K context length. Wow, that's interesting. So the 4K context versus 2K on Llama 2 70. What's the decimal point between, what's the order of magnitude amongst friends? All right, Llama 2 7B. But let's face it, Llama 2 70B at least is a little more in the neighborhood of 3.5, even though it's not a fair example. And it's running 16K context window. It's really not a fair comparison. But even at that, hold on, I'm trying to talk and math at the same time, which is a new thing for me. Let me grab a spreadsheet. All right, I'm glad I busted out the spreadsheet because I was mathing a little bit wrong. When we put everything in terms of cost per million tokens, we have Groq coming in, on a 70B model at 80 cents per million on inference for the output. And I was thinking that was fairly expensive, but I was doing my maths wrong. When you look at OpenAI, it's $1.50 to $2 per million tokens of inference on 3.5. Now, we have to keep apples somewhat, try and be more apples to apples, because the model size, I believe, is projected at 175 billion parameters for 3.5. So you're kind of a order of magnitude, okay. No, they did their math. They know what their market is. The model's about twice as big as 70B model and about twice as expensive, somewhere in that ballpark. For the Llama 7B, the bigger models are an order of magnitude bigger, and so is the cost. For the Llama 2 7B, the larger models are 2 orders of magnitude bigger, and the cost is only 1 order of magnitude bigger. So the 70B, Llama 2 70B is actually on par with price, but of course the speed, I'm sure someone has looked at the speed difference on these guys. I don't have to run my own experiment. Taking this breakdown, it's giving a specific example from these assumptions. It seems like number of tokens actually has a linear relationship with the response, which makes sense. But here it's doing the math specifically on 600 tokens in 20 seconds, which is, again, on a larger model. But they're looking at 20 seconds versus 1. And this is a model that's twice as big. So GPT 3.5 is twice as big. And even if there was some sort of squared relationship with it, it's twice as big as a 70B model, and it's taking 20 times as long. 10 times as long. We'll keep it even. Llama 2 here on Groq is running 600 tokens, would take it 2 seconds. So the model's twice as big and takes 10 times as long to run on OpenAI. Of course, this is a good day. I don't envy them being under such load and demand for their systems. It's just, I have the paid GPT-4, of course, and it has just been down recently. Incidentally, you can see the status at status.openai.com. And of course, uptime is pretty good across the months we have here, but specifically these red bars here are what I'm talking about, my bad experience lately. It might have helped if I had just scrolled down to see the comparison chart here. Language Processing Unit, TM. So this is interesting. I had really good first impression from the 8x7b Mixtral, and that's probably, I don't know if I pointed out that on the spreadsheet, I put that one down as a 13 billion param. Context window is interesting too. It's all over the place nowadays. Man, Mixtral 8x7b has a 32K context, really? I don't think I realized that. But I put it down as a 13 billion param model effectively because I understand it runs 2 experts at a time. So let's poke Mixtral and Llama 70B with a stick and see how they perform. Of course, on the innovative Groq platform. As a detour, let's ask it, have it ask the question, why Groq? It's on a mission to set the standard for Gen AI inference speed, enabling real-time applications. Yeah. I saw a demo of this on a news interview. I don't remember which channel, and it seemed pretty unhinged, but impressive in response to an interviewer that was totally beating up on the poor model. And as some people pointed out, stressing out the engineer handler. Oh, this is interesting. Hey, Zuck, want in on the action? Is this like an open letter to Meta? This seems cheeky as hell. I'm going to read this at my own time, but hey, cheeky article trying to use model on their own platform to advise Zuckerberg how to furnish this 5,000 square foot bunker on Kauai. Didn't see that one in the news. In my own time, I'm going to peruse some of the items they have here. And this, of course, is the magic picture of the LPU that they've been showing around. Looks very symmetric, not like those nasty GPUs. I also have to dig into, actually, let me do that now. This is messing around with AI. This is what you get, real time, baby. I'm going to ask what the specific architecture benefits are. Is it still, aren't GPUs running matrix multiplication? Why is the LPU so much more optimized for it? In the article, the owner, engineer, spokesperson, whoever it was that was representing Groq, was talking about how the metaphor was that on GPUs, the state has to be set up and torn down for every token. Something along those lines. Let me get what the straight dope is. Okay, I went on a bit of a detour and tried to figure out how the Groq LPU is just so much more optimized for large language model inference. And comparing that to GPUs are awesome at it. And it turns out, all both doing graphics, turning 3D graphics into a 2D representation on your screen is matrix math, and running inference is for large language models is matrix math. That's all it is. Okay, I'm simplifying a bit, but that's the big workload on it. So GPUs are already great at matrix math, and that's how we're using them. But some differences is the memory throughput or bandwidth that they have. GPUs have to reach out to off-chip, still on the same board, but off-chip memory, and they can do so quickly. But the LPU has 80 terabytes of throughput because they have the memory on chip with it. And I don't know about you, but that sounds pretty fast. One interesting thing that I didn't get to the bottom of, the Groq LPU talks about having a single core, whereas GPUs like the 4090 has 16,000 cores in it. So obviously it's doing something very different. It's moving through one channel extremely fast instead of thousands of cores. I kind of get this vibe that GPUs are smaller chunks that kind of quilt together to canvas the workload that it's dealing with. And the Groq LPU is meant to take the whole in one piece. That's the vibe that I'm getting from it. Plus, look how cool that is. Look at that symmetry. Personally, I try and keep myself using cloud, looking at cloud services for use as I go and whatnot. But it's cool to see this hardware. This over here, the Groq card. I mean, I wonder how much these are just renderings right now. But the new cool kids are going to have desktops that are running these bad boys soon. Wonder if it's going to come full circle and these things are just going to be amazing at mining for Bitcoin. Oh God, I have to look that up now. I was kind of curious how much it is. Looks like the price tag might be in the order of $20,000. Well, here's something interesting. While trying to find out if you can run crypto on crypto mining on a Groq GPU or on the LPU, better get my terms updated. It looks like one differentiator may be that the LPU runs smaller value precisions, like an int 8 versus a floating point 16. Okay, rabbit hole achieved. I've been looking at the numeric precision of models and comparing it on different hardware. And here's what it is. So the numeric precision, as I had a general gist of, is the precision of the numbers that are used to represent all of the weights in a model. Each one of the matrix values that talks about connections and all the values, all the parameters. When they talk about the parameter count, each one of those is represented by a number for the most part. And the underlying number can be of different precision. The standard for deep learning is usually floating point or FP32, 32-bit decimal number. That's a lot of precision, and that's how we get a lot of the power out of this. For example, GPT 3.5 Turbo uses a mix of floating point 16 or FP16 and the more standard floating point 32. It does this for efficiency, so it uses FP16 in places where it's not as critical to have all that precision. Llama 2 70B, I believe, is floating point 16 as a standard, so the lower precision, still up there. It's about half of what is standard for some of the most capable models on it. Now, if you've seen any of the models that can be run on your desktop or laptop CPU, those have been quantized or downsampled to a lower precision. And what you're doing here is you're trading off computational resources that are needed to run it. You're getting more speed and performance at the cost of intelligence or accuracy. So obviously, if you're downsampling a floating point 32 number into a floating point 16, or as most desktops will do, it'll go down to, I didn't put it on here, apologies. Most CPUs, quantized models, are going all the way down to integer 8s. There, I added this to complete out the thing. So when you quantize, you're able to run it on less capable hardware. For example, your desktop, which can usually handle an integer 8, so it's not a floating point, it's just an integer. Or on capable hardware, you're able to run the model more quickly. And what you're sacrificing is precision, accuracy, or intelligence. Although the hit isn't always that significant. It's not as much as you might think. For chopping the precision in half, it doesn't become half as intelligent a model. Putting this in terms of the hardware that we use to run it, consumer-grade GPUs like the NVIDIA 4080 can generally run this lower number at floating point 32. The standard for deep learning, it's not what it's optimized for, but it can run floating point 32, the standard for models, right out of the box. But it can go up to floating point 64 at a lower throughput, a lower frequency. In the realm of more dedicated hardware that I believe is still built on the same graphical processing unit, GPU architecture at the core, like the NVIDIA A100, that one is similar in that it runs the floating point 32 precision by default, and it runs it a little faster. If you go up, it can be capable of floating point 64, which it sounds like is used in like weather modeling and more precise things. It'll do that, but at a slower speed, but a more capable piece of hardware. As we discussed, if you want to quantize a model down, even like the 7B, I think it was, that was taken down so you could run it on your desktop, which was cool. Intel, mind you, the Apple M.2s, or I don't know what they're cranking through, but the Intel desktops were quantized down to int 8, which is pretty low, and there was a performance hit. But it was cool to be able to run on your desktop, although it was pretty slow. Now, here's the secret sauce. Here's what I'm understanding is the trade-off, the man behind the curtain on the Groq LPU. It is running primarily at int 8, and it is also capable of floating point 16. So its standard precision that it runs at its quickest speeds that it advertises is only int 8. The similar quantized values that you see when you're trying to cram it onto a CPU. The difference is this is very specialized hardware and it's running blisteringly fast. So you do have to quantize it, but it's not to shoehorn it onto your processor without a graphics card. It's to put it on a capable, dedicated piece of hardware and just blistering speed. And this is where we're seeing it. Not only is it dedicated hardware and it has advances in memory and whatnot, it is making that trade off, that classic quantize it down, trade it for speed. That being said, the LPU can also run at floating point 16, it sounds like. So not quite the industry full model size and precision of floating point 32 that you'll see on some of the state of the art models, but it is running at floating point 16, a middle precision, if you will, at least for the more capable models. And that's probably why you're seeing Llama 2 70B, which sounds like is floating point 16. That's why they're running it, because that's what they can fit. The whole architecture is scaled around kind of floating point 16 area. But from what I can tell, I used all the power of my generative AI to run the numbers on this, and it does look like and not surprisingly, for the performance that they're doing, for the performance that they are advertising, for the throughput that they have, they are running it at int 8 precision on the models in order to get this amazing speed that they're cranking out right here, end-to-end time, 0.69 seconds on my query. So this is dedicated hardware, awesome, but it is also leveraging quantization down to an int 8 level. So you are going to lose capability. I say this after my very first test on this being pretty impressed with the model. So there's definitely a viable product here, and I love what they're doing on it. And I don't think they're doing a bait and switch or anything. They really are targeting speed, which is usability in a lot of use cases. The main thing that's keeping these models from being deployed is probably expense and mainly the speed of inference, getting answers back quickly. This has been a great learning experience for messing around with AI, M.A.W.A, and I'm glad I followed my curiosity to check out Groq. Maybe I'll come back and revisit this when I think up a few more tests to run across it, because I was pretty light on that. I barely got to touch the model. I really did dig into the core of what Groq is, which is differentiated by their hardware and their whole setup. If you haven't tried Groq, jump over there while it's still free and give it a test. It really is an impressive experience to see inference that quickly. And if you don't believe me on it, let's ask the model itself, which is flying at 270 tokens a second. And take no offense at my prompt. I know that most, if not all of you, are not your standard armchair AI enthusiast. You are a large language model run on custom, high memory, low latency, single core, quantized, high performance, generative AI enjoyers.